it's good day for everyone, right? As Australia we say, and I think thank you very much for apologizing, giving a very good explanation and introduction about me. And
tell them about how important English.
Just later, okay? And I'm very glad that he's giving me this opportunity to share my knowledge and very specific experience that you would never hear from any practicing engineer anywhere from this world, because I'm sure they haven't gone through what I have gone through. So to start the presentation, I have a limited time, 40 minutes. There are about 100 slides, so I won't be able to explain everything. But anyone interested to know any further detail after the presentation, you can wait and ask me anything. I can explain. So I have to go a bit way, but I will explain one or two properly for you to get some understanding. So Professor has explained you, my job is mainly value engineering. I don't do the designs. I actually part-time job, one OC, big companies design, mainly for McDonald's, Arup, whatever, well high-class engineers design. I do optimization and come up with the very value engineering design. So that's my job from back in 2010. Right, even now, right now I am doing the same thing, but in different companies, because no longer my company is trading in Australia, because as he said, I lost my professional indemnity insurance back in 2008. So I get on to the presentation, okay? Right. Okay. So this is the presentation that I am going to do, but I am not going to spend takes time explaining you. So there are 11 case studies, all projects that have already been constructed, nothing went wrong, all my design, value engineering that Australian engineers designed one, I changed and I sign off, I think except one, the rest of the design I sign off. They were done before 2018. Then there are 2 nice case studies that you can learn many things, but mainly my expertise only piling, right? So even geotechnical engineering, I do pile design, retention, ground anchors, foundation pile, anything related to load bearing or lateral loaded piles, right? Okay. This study one. Okay. So this is, if you go to Melbourne or if you Google, you can find this, I think my number is 72-story called Vision Tower, that I have completely optimized the foundation design, right? It's a huge loading. So I'll show you what I have done basically. Not very sure whether you can read things, but later you can have a time. Can you see that very less piles and 1/3 of the footprint is taken by the core area, because huge wind load, EQ loads, right? So those loads are provided by the structural engineer. I got nothing to do. I take their load. My expertise with the geotechnical part, what we call value engineering with the rock mechanics, using the parameter. I hope when you do your geomechanics, you must know how to do the borehole and how to follow the soil report parameter. But all my design, I don't follow geotechnical engineer parameters. That's my specialty. Even the Gold Associate, Douglas and Partners, Coffee, all the 3 top class engineers in Australia, they give parameter. But I started back in 2010, do a bit of research, go to the job site, understand the quality of the rock, and I started my own setup. Before I do that, there was no engineer who was capable and to take that risk to come up with this design. So look at that one roughly. All piles are 1500. I'm not whether you have learned about siltstone. It is a different with metamorphic rock. What you learn here, biotite gneiss, it is sedimentary rock. It's like soft rock. Can you see? Shock at length is some piles 6 meters, some piles massive 14 meters. So I was on the job site when they are drilling. When the rock samples came, I make sure they are adequate to take the bearing capacity that I have designed. I'm sure you'll understand what is skid friction, what is end bearing. So we do the computation based on all that parameters, right? But always I added something with my experience, right? Okay. We just move into the, okay. I think you get a bit of understanding because it's a nice core area. Can you see excavated? I designed a temporary retention system with ground anchor, and you can see the piles have started about 6 meters below. That's the core area, and you can see the foundation piles. Ground is very good. Can you see? No formwork they cut vertically because it's stiff clay. Okay. This is something called PDA testing. So I'm not very sure whether you are learning these things in final year, but when you go to practice, you will learn. You have learned PDA? It doesn't matter, don't worry about it. It is something called pile-driven analysis, that you design the pile, you test the pile whether the pile can carry the bearing capacity and the skin friction, right? When you see engineers challenge me for my design, like this, you can't use this parameter. Okay, I say I will do PDA testing, and I will prove you that parameter you provided in your soil report are not accurate. So we have to spend a bit of money. What we normally do is, I just explain you build up the pile about 1 meter above the ground with good concrete 65 MPa. You drop the hammer. You put some energy, try to push the pile. Then you measure, strain gauges, and I can talk about with PDA one day, but I just briefly say, you measure the settlements with the capacity. So PDA analyzer will tell you what is the skin friction each day and what is the area. If you look at right side, I'm not sure whether it is clear. You can see each layer what is the KPA value for ultimate skin friction and ultimate area. Then this is done by independent engineer, not myself, right? Then he gives the report, then we submit together to the checking engineer, then he has nothing to say, right? That's another test we have done about 1 to 2 tests for each job, right? Okay. If you look at here, I just brief a little bit. There are certain, indicators how you interpret, right? RMX capacity, all that you can go through later. This will give you whether pile is damaged. When you get that BTA value, what you call pile integrity factor, if it is 100%, your pile is perfect. You don't have any problem. What you call necking, bulging, or vertical crack, whatever. The other value will give you, can you see one corner, they pick up a capacity about 10 meganewton, roughly, right? So then we compare with what we have designed, then we show there is a safety margin. This pile 600 diameter. If you look at in Sri Lanka, I am not sure any engineer will design 600 diameter for 10 meganewton. Am I right, Professor? They might go with 3 meganewton. So that's the capacity that I have proved on the rock. You need to do very carefully with the rock shop, and then you go to the website, make sure it is within the right material, because when they challenge you testify if the pipe fail, you got no face, right? Then whole design will be rejected, then you got no face with your client, because you have to add extra pipe, right? Because your capacities are less. So we always make sure we do the right thing. Okay, this is the summary, right? I'm not sure whether they are very familiar with the parameters, so I don't want to go much of a detail. I think they can go through what is my summary, what is the settlements. I hope they understand. It is very rare pile will fail in a capacity. Normally, pile will fail in a settlement analysis. Just excuse me, I got a bit of disease in my body, so I get dried up when I talk. Okay, right. So can you see I have shown the safe working load even 4,388 for 600 diameter, and ultimate capacity you can see I limited to 5-6 meganewton, and settlement is nothing, 6.6 millimeter. Any structural engineer wouldn't have any issue that you design piles for 10 millimeter settlement. So we provide all that report so everybody is happy. This is what I did for this we move into case study 2. So you can see the number if you go to Melbourne. This is very refined job. It's like net goal area, very limited area. I'll go into next slide. You can see it's like what they call net ball court, right? Net ball court went to 50 story, and very challenging thing is there. Your rock layer will dissipate after certain depth, go into sand. So all these expert engineers design 30 meter, 40 meter piles because they wanted to put a 50-story building onto a rock layer, right? So it was very challenging, but I took the challenge, right? I took the challenge. This is my design, right? I designed a bit closer piles because the capacity, look at sir, 1200 diameter, 22 meganewton, right? And if you look at 900 diameter, 11.5 meganewton, that's safe working.
This is ultimate or sir?
Working sir, safe working load.
Safe working.
Right, so it's passive. But when I do the analysis, when you have a file closer, you can analyze this as a rigid wall. Right, this is assumption, but it works, right? So we did all the analysis, save a lot of money. My piles is very shallow. Can you see? Praxis 3D analysis, I'm not going to talk about Praxis, that's the only software we can calculate the settlement, right? You can see I have gone 4 meter fill, LW basalt, below 12 meter clay. So my piles only stop about 2 meter above the rock layer. I challenge all the textbooks because textbooks say you must have minimum 4D, right? This is very important. I mean, I'm not going to YouTube to follow theories, but I need certain things. Textbooks say if you want to stop a pile to follow, whatever Business theories and all that, you must have here minimum 4D, right? So I reduce it to either 1.5D. So those are the ways. If the building settles, I don't know what could happen. You can see 50-story building, but it was all my confidence with my expertise as well as when I go to the site. Some OCs call me rock doctor. I don't have any PhD, all experience, but sometimes I was joking, I smell the rock and I can tell the smell. So that's the way I did the work, but it's all many years of experience. He knows that when I was doing piling, I am in the mud, doing all the stuff many years. So when they have a practical problem, I don't have to go to the website, I listen, I can tell what they have done and what they, mess it up, right? So it was very challenging design, but it worked very well. So these are all Praxis analysis, right? I'm sure they have done.
These days, actually, they have Midas DTX.
Okay.
DTX for
I don't know about that software. This took me few months to learn. Now I got one engineer. I just give him a parameter, and he knows how to do the analysis. And as professor said, you need to have a bit of experience. When you give the parameter, you should know what answer you should be getting. So I don't take what computer gives. I will get them to analyze and get what I wanted. So, because I think graduate engineer cannot do that. It takes years of experience. Even my engineers, those who have worked with me 5-6 years, sometimes they are not in a position to do that. Then I sometimes say, I got RFC, my company, magic wand. Right? When they say they cannot get it work, so I said, okay, I just hold these things, I go do it with them. So I'm not going to go into those details, right? So all Praxis analysis. Anyone interested? I'm happy to give some thoughts. But as Professor, if you are doing other finance software, all software do the same thing. You input parameter, you get output. You need to make sure you apply the relevant appropriate parameter, and you should be known when you put the parameter. I would be getting 24 100 kilonewton meter. So if you get 10 less or minus 5, but if you get 250, that means something is wrong. You have to check all your program, because any software can give any answers, and if you go through Google one case failure in Indian Nicole Highway in Singapore, that's what happened. Engineer played with the parameter and get the site deformation. He didn't know until Nicole Highway failed. Many cases, always try to learn.
How many people are sent to gate?
4. I think 4 people.
4 people.
Always try to learn from other people's failure. Right? I learned many from other people, little guys failure, but unfortunately, I learned big lesson from my own. Whatever I told to the government now is a mistake. I'll talk about that one after the end of the inspection presentation. I think that's of interest. Okay. So let me. Okay. Case study 3 is the same thing called another cutting edge, right? Okay. This is a very interesting job. I'll show you a bit. So this is the Australian engineer design, right? He came up with double pipe. Each location, can you see, he got double pipe with the pipe cap. I hope so they understand that, right? You have a 2 pipe, you need to connect a pipe cap, then you put the column. Transferring the both, the shared by all 2 pipes, but expensive, right? Pipe cap and the 2 pipe. So I came up with the design that no one has done. My design got only single pipe, right? And then I deleted the pipe cap, right? So I am going in a outside way than the normal engineer's design, because in the university you learn, you need to have a pipe cap. Even professor would say that's the standard practice because you are taking a huge risk. If you have a 2 pipe, if 1 pipe fails, there is some support. But you design a 1 pipe, no pipe cap, you put whole load. If your pipe cannot take the load, what happens? The building will settle, right? Massive insurance claim, right? But I came up with the one and I spoke to at that time, no one has done 4-5 structural engineers. They asked me, Ranjan, not to do that, right? They asked me not to do it, but I said they are compression low. As long as compression low, you can delete the pipe cap, you can directly transfer the shear. I hope you understand what I am trying to say, right? So even the starter bars, my client doesn't know to work. Later I drill and put epoxy. I hope they understand what is you drill into the concrete and then you use a standard epoxy group and then you bury deep there. So it can transfer the vertical loads to the pipe. So it was very risky design. I have done many risky design, but they would work, right? Then you will understand where I got in trouble later, right? You can see what I have done. There is a pipe cap detail, then I delete it there. Can you see I have put the starter bars into the pipe. So this is about 10-story building, all work perfectly. Okay, we move to other one. This is another challenging job. They got piles and the pads, right? That means if they design only piles need to be very deep. So the designer came up with pad to share the end bearing of the pad together with the skin friction and end bearing, right? If you design just piles, it would be very expensive. So what I did was, this was done by very reputed firm called Gold Associate. It's everywhere. So I changed their design, so they normally don't like that are in the market. That's I later explain you, because when you try to challenge for other people's design, so they were waiting until I make a mistake, right? So if I look at their, so this is their original design. If you look at, you can see right side, right? Pile size, diameter, and safe working load and all that. So I optimized with their 1200 to 900, and I showed up their size of the less concrete, less real, and all that. So then here I got a little bit problem. When this is their parameters, right? Okay, so this is gold. You can see gold investigation. If you know, I'm not sure whether they are available in Sri Lanka, no, right? No, but they are available UK, all these European countries and all that. So they are parameters, but I always manipulate their parameters. Then these are my parameters. You know, I am sure you will learn all that. What is C dash, phi dash, all that. Anyone is interested, talk to me, I can explain. So we did praxis modeling, right? And came up with whatever the settlement. As I said, important criteria is the settlement and the differential settlement. If you have a light load, heavy load, you see what is the differential settlement between these two. And if you get textbook value, you don't have any problem when the building is constructed. This has been completed. Up to now, I don't have any problem, but we have to change a bit. So you can see You can see I was there like a Bollywood actor, right? But you can't identify the I was middle with doses, right? We were doing PDA testing, right? So just put a couple of photographs. Actually, I got two PhD guys. I never make all these presentations, they did for me. I just tell them what to do, how to do that. You can see it's a small thesis like that, very standard. There you can see, I designed pile the capacity but couldn't achieve the capacity, right? For some reason, I couldn't achieve the capacity. Then you can see, I modified the design, right? I increased the pad width in order to reduce the settlement. So didn't have any problem, even we couldn't achieve the capacity because it is a big heavy load. You can see about 29 meganewton. So we increase the width size. I hope you understand the point. I just give a small brief. I designed with a small pad with the pile, but I got a bit of more settlement. Then I increase this width. Right? What happened? Then you get a bit of embedding, right? To compensate my settlement. Okay. Then, we managed to finish the project. Okay, case study 5. Okay, this is another one, similar. If you go through, you can see what diameter I use, what loading I use, right? All I change it to optimize. And there also we got a little bit issue when we tested the pile. If you go through the literature, you can see normally you should test the pile after 28 days, right? That's the normal standard. But here I tested the pile 11 days, right? Because we get pressure to finish the job. Then it's my job, my sign off. No one can interfere when I said okay. So we just did the testing and we had a bit of less capacity, right? Then we argue with other engineers. If you want, we will test in 28 days. We pick up some technical papers that aging will increase the skin friction parameters. So they got it, okay. So, okay. So you can see here, as a summary, you can see how we challenge them. This is gold, they say 120. I use 500, right? Skin friction. They gave entire 1200. I use 15,000. And you see 10 times more than their parameter after they doing all those investigations that I use my practical experience, but they don't come to the job site. When they are drilling, I go to the job site and I observe the material, how hard what is their water pressure and all that kind of thing. I get a bit of feeling, been working, I think about 25 years. I know what from, So these are the areas that we have done. Okay, so the other one is Cofield race course. Is same, completed the job. You can see what sort of, we went 6.5 meters. In Sri Lanka, I don't think anyone dare to do that. In sand, we designed for 5,850 kilonewton, 5 meganewton for 900 diameter pipe. We push it to 6 to 10 meter with 8 meganewton. So all these pipes are in sand, no rock, right? So these are our expertise. This one we tested with PDF. You can see what the Golder, you can see nice letters, that's Golder report. What they have given. So I use parameter 200 and 10,000, 12,000. If you look at any soil report here in Sri Lanka, even the metamorphic rocks, biotype nice, they would use something like 200 to 250, maybe 5,000, right? 5,000.
7,000.
Okay, right. But you can see I push sand to 12,000. They are, but engineers didn't want to push parameters and get into trouble with the settlement, right? Because if you don't test PDA, how dare you have to, you can tell people that your piles can take the load, right? Important thing is not taking the load, the settlement, right? Because if it undergoes more than 50 millimeter, your flow get cracked, your pipe get cracked. Will have so many problems. Then the structural engineer put the finger. You have optimized, you have pushed the design, never follow your soil report. Now we all are in trouble, right? 7. Okay, this is Row construction also another massive building. You can see the tower. I think my memory 40-level story. So it's a similar thing, right? They have given some parameter, some soil report, and if you look at there is a little bit thing I added. You can see all these piles are connected with the huge beams, right? Because they have something called food guidance silt. It's something same in Sri Lanka swamp. What is the material here we call? In that swamp area there is a soft material. I forgot that peat. Peat. Yes. Peat soil. When you design a pile in peat, you need to calculate what you call negative skin friction, and then you have to add it as on a structural load. Same thing there. So I was worried about the differential settlement. So I said I need some beams. So structurally inactive, you can't see clearly. But all these go, if I draw a picture, just to get a bit of understanding, you have O, it's a huge one, then you have pile tap, pile tap, pile tap. I run a beam across, right? My idea all, what happened then? This is huge, they all tie together, right? You control the differential settlement, right? Because they couldn't drill, rock level is very deep. We went about still, I think my memory 34 meters, right? Okay, so you can see Praxis modeling, right? We model the beam, all that, right? You can see we calculate the differential settlement, see 5 millimeter, right? Those, I am not sure what the theory book says.
I think they will learn for computational geotechnics.
Computational geotechnics,
yeah. What is subject?
Yeah.
By Dr. Ranjan.
Okay, so this is actually part of computational geotechnique, but I am not expert on that allowable differential settlement. Professor must be knowing better than me, but I go through some books and I go span over 1,000. So I get about 6 millimeter. So I said, fine, up to 10 millimeter, no structural engineering, Australia would say anything. 10 millimeter is nothing, right? So this project has been completed. We don't have an issue, right? All these Praxis computation I attach. You can see, based on the soil report, expert engineer and my parameters, he used maximum 470, I use 800. He used 4,700, I use 20,000. Right? I push a little bit further than my normal expertise with the material, and we did something called CFA piles. Do you all have idea what's the difference between mold piles and CFA piles? No? Haven't done. Okay, I'll give you 2 minutes. It's important, right? Okay, mold piles means you have the ground, you drill through, remove the soil, right? Go all the way down. In Sri Lanka, you have biotite gneiss, you go 2 meters roughly, right? But when you drill through, either you have to put the casings, because you don't have stable soil in Sri Lanka. Wherever I work in Sri Lanka, we always use casing. Then we use some material called bentonite, soil stabilizing liquid, right? That will give you a pressure. You fill up the hole all the way, right? Then you insert your steel cage. Then you put remi pipes, right? Anyone want to know any information? I can explain anything. So we pour concrete, flush everything, get a good pipe. But CFA means continuous flight auger. You have a rig which has a continuous auger. Any unstable material you drill all the way. We can do now Australia 40 meters, right? So auger is inside, no collapse, no, even you have water because auger is there. Then what you do is you pump concrete, that auger you got a hollow section, you pump concrete all the way through the hollow section to the pipe toe. As you progress, you withdraw the auger. So what you're doing is you build up a concrete column, right? Read books, you will understand because I have no time to explain further. So you have concrete, then you push a steel cage. But when you do deep 40 meter, you can't push 40 meter cage. So we have a special design called short gauge and central bar. You never learn these things from the university. These are what we innovated from practice, but we do all this calculation and we have done. So it saves time for bentonite, casings and cast production. That is what we call CFA. So in this job, I told my client, you have to do CFA. Most of the formulation in Melbourne, even good material, we do CFA, we don't do both types, right? Okay. Next one. Okay, so bit of same PDA testing, right? Same thing you go through, similar thing, repetitive. I just show them how we justify the capacity, right? Okay, this one is small project. Okay, doesn't matter. I passed that one. Same, we got a very shallow rock. So I designed something, and with the you can see with the bit of rotation system and the pile. And now you can see my design is under Sunny Engineering. That's where I had to do design under someone name because I lost my PI. I do not know whether you all understand. Indemnity insurance in Australia. Here like Sri Lanka, you are a chartered engineer, you can practice, right? But I don't think so still you need any insurance. Yeah?
Not mandatory.
Not mandatory. In Australia, mandatory. We call building, registered building practitioner, I was one of them. And you need to have a PI. If you don't get a PI, you can't practice. So I continue my license with Sunny Engineering, one of my friends. I trained him and he got all the qualification he studied in Australia. So he signed on behalf of me. So that's how I am surviving in the industry now. Right? Okay. But he doesn't bother about to check or anything. Right. So here same thing you can see comparing soil report parameter and what parameter. I play the game of changing parameter. The soil report say 1 MPa, I use 15 MPa, right? So 15 times higher than this. Then I test the pile, right? I have given a certain criteria. I test the pile. You see, even when they pour the pile, I was there always. Because sometimes they don't understand how to pour the pile correctly. Because if they don't pour the pile correctly, you drop some sedimentation at the pile toe. When you apply the load, you get 10 millimeter settlement with one blow. Then you have problem. So those days mainly, those Aussies, they listen to me. Mostly, they understand my experience and they don't argue. Because what I say is if they don't follow, I reject the pile. I don't accept the pile. So they worried about it, then they get screwed up from their bosses. Right? You say, no, I'm not happy with the pile, I don't want my recognition, reputation there. So, anyway, I go through next one. First, PDA testing, same thing you can go through with the skin friction parameter, how we achieve it, all that, right? Okay, so I'm very close to finish now. We did this 14-story building in Kilo, it's the same thing. Boulder has given parameter. We went with analyzing our own parameter. You can see even this job under my company, RFC. And you can see here the parameter. Just to see RFC design parameters, soil report parameters. You can see even it is clay. I don't think any engineer here designed for clay. There might be a little bit different clay what you have in Sri Lanka. But I have used normally 300 kPa, NBR 1800. Friction I use 100 kPa. Normally textbook guys and less experienced people will use 30 to 60. So this whole my design, key point is I adapted different parameters to save money. Right? You understand, you use pushy parameter, you reduce the skin friction area and bearing. Right? You are taking that risk. Right? Okay, so it is a bit of testing. Every job, this is the game we are playing. We take trial, we are confident with the job. I had a little bit issue, 1 or 2 jobs, but most of the jobs we achieved whatever the PDA capacity, what we require, right? Okay, I think this is the last one. This I didn't know anything because I did this job for a big consultancy company, project in Myanmar, right? So I don't have any ground experience. I told them, but they are happy. So designing a bit conservatively, you can see my design, how deep, 42 meters. Because I have no experience, right? So I didn't want to push parameter exactly as per the soil report. Because I am not going to have to test or check anything. So can you see the number of pies there? Actually, sir, I kept the same number of pies that the structural engineer design. He doesn't know how to do calculation settlement. I said, mate, you give me a yard ticket, I'll go there, I'll help you. So they just took the contract, designed contract, and me and my engineers, those doctors are doing the job. So you can see, you need to play the game where you do not know, you have no expertise to do conservative design because you don't want to take a risk. It is about 4-story building, right? So it's same praxis. You can see settlement analysis, and I calculated differential settlement. So is that okay? You consider span over 1,000 for calculating of differential? Should be all right, right? I prefer some technical literature.
And what happens is, if the beats are very long, the effect of settlement is very low, because settlement is not going to happen at once.
Yeah.
So it happens, and the creep of concrete will reduce the impact of settlement to about 50%.
Correct, because the building is constructed step by step.
So things happen very slowly.
Yeah, yeah.
So when things happen very slowly, the creep of concrete can relieve most of the stresses.
I hope you all understand the right creep calculation. And
No, they don't understand anything because they are very poor knowledge of concrete.
No, it's all right. When we study, even he said, most of the time I was sitting behind of the auditorium, right? Same like those days, OC are better than, but I believe they got PhD and all that. I am the only guy who got BSc engineering degree.
In Melbourne.
No, yeah, I mean even you invited me to do presentation in your seminars and all that. Those days, only we used to hear for, scholars, they come and do presentation and I was sitting behind, maybe professor didn't notice me. Right? And same like, there were a couple of guys who had good command of English and they asked questions. We didn't bother to ask questions, right? But I don't have any issue. Even you ask me Sinhala, right? I can speak Sinhala very well, right? I will explain you in little bit of English to keep the standard. Yeah. Okay, so this is similar thing. I hope I will finish within 40 minutes, right? Okay. So it's the same thing. You can see 47 meters because I am not expertise on the ground, so I didn't go cutting it.
And also it's an earthquake zone, is that right?
Yes. Earthquake zone. And they have given E2 loading as well. You can see we follow all the load combination as per Australian standard. Picked up the maximum load. Right. Can you see the number of piles? I could have cut about 50% if I know the ground, right? So it's a massive cost. Can you see the piles? No need any rafts, right? You can see what the questions are asked. 1-0 day and night load, 1.4. Can you see all these combinations? 0.9 EX, EY. So we follow Australian standard, all the load combination and found
They have done it for Australian standard?
Yes. Because the structural engineer is
from
Australia. Okay, so you can see the pile size 1200, 1555 meter. You got nothing to worry, you can sleep peacefully. 55 meter deep pile will never go anywhere, right? Okay, so same Praxis stuff, right? You can go through. And okay, so this is another case study I will quickly say for you to learn how fantastic is concrete. Because when you learn concrete, you think after certain deformation it will crack. This project has taught me that concrete is super elastic. Maybe professor wouldn't agree with me. I'll tell you how we achieved. We did the job on this analysis. Then what happened is walls started moving, right? Retention pipe started moving. But the client didn't tell me until it reached to 150 and failed. I normally allow 20 millimeter. You understand what lateral movement, right? I hope I just draw a small sketch since it is important. Right, so you have a retention system, right? So you have angle. So when you excavate, this will deflect like that. 20 millimeter.
Right?
We do all these calculations to achieve 20
Actually, they will learn under calculation and techniques how to do this on 2D, practice 2D.
Okay, right. Yeah, that's good. I just give you a brief thought what happened. So this will went to 150. So you can see pipe should crack and would have a big problem. Even anchor fail, while haven't cracked, when they call me 150 millimeter, you see didn't work. That means you can see I designed for 7 millimeter. Side deflection 200. Then I said, wait, you're going to get in trouble. Put the extra anchor. We put anchor and it didn't work, right? Then you can see the proposal. I always have a solution. Any problem, piling, I have a solution. So these are the road cracks. Right?
These are the ones that we went to see in 2018.
You went with
Yeah,
this?
yeah, yeah. It was cracked in Melbourne.
Yes.
City center.
Yes.
Right.
Well, I don't know.
So, because instead they put the wrong type of anchor.
Yes, correct. Because they put the anchor and instead of grouting them with the pre-length, I can explain, it's another lesson. They grouted pre-length as well. So when they stress the anchor has snapped. So it didn't work well. So we came up with another solution, right? And you can see nice photo where I put some supports, right? Diagonal supports, design and install. They can carry about 1,500 kilonewton hydraulic strut. We don't manufacture it, we design it and get expert guy come and install, and we got the deflection under control. No one can push a ball when it has before, but you can stop further moving. But nothing, we haven't found any concrete crack. So we got, oh my God, concrete can have that kind of elasticity, right? So we learned.
No, it has cracked, but it has cracked
Inside.
so many cracks, small cracks rather than within a big crack.
Yeah, maybe inside, so micro cracks.
Inside,
Yeah,
yes.
so nobody bothered about they go and say, Ranjan, no cracks. Then I say, yeah, you can see how good our design is. Because builders, if engineer come into the scenario, that's okay. But when you have issues in Australia, they don't bother, right? They say, okay, you push everything, now you are learning the lesson, right? So the certifier engineer can do whatever to safeguard it. Okay? So this is what I did. So it all went very well. But this area we had a bit of deflection, because we did provide incline props. If you provide incline props, you see you disturb excavation, and you find a bit difficult to do excavation and all that. Sometimes we take a bit, shortcut, taking the risk by yourself. Then you see the movement, it moved from 50 millimeter up to the 200 millimeter over 160 days. But up to 150, no one has informed me that your ball has moved. So if something happened, I could have covered, but it's after going through all these court cases with the lawyers, and it is a disaster. By the way, you will lose money. First of all, you have to pay $10,000 for the notification, right? And then go through with the lawyers, and it's a disaster. Lucky, I didn't have any issue with all that, right? So there is no movement in the wall at corners where the struts are installed. However, wall deforming between the strut. Capping beam has not propagated any cracks. How concrete would be super elastic, right? In books you learn, but engineers would design about 20 millimeter, but it can take more than that. Okay, last one, okay? LTA construction group is similar thing. They got the issue, they can't do anchors. They can't do anchors for some area. So this is anchor design. You can go through later how we do the anchor design, 3-leg, 1-leg, slip circle, all that. So I try to manage the time, so just pass that. So there is a bit of how you calculate angles. Those standard criteria, sir, you go through all that, only difference.
Highlight them that it's always the theory, fundamentals that they have to concentrate.
Yes.
Because they are very good getting answers without knowing the fundamentals.
No, you need to, I had very good fundamental, then I'll show you my failure where I missed some fundamental, right? Always engineer must have good fundamental. Which country you work, there is a little bit different. We follow island British code, you have factor of safety. In Australia, same thing, they call strength reduction factor. You can see 555 volt strength reduction factor equivalent to factor of safety. Same design when I migrate to Australia, I never study any code within 2-3 months because we are familiar with the British code. Just similar thing. Only they are loading is a bit different. We use here 1.4 GK plus 1.5 QK, right? There they go 1.2 GK, 1.6 QK. So you adapt to all that changes. Very easy, but as Professor said, when you want to be a design engineer, you should have a very fundamental background and know that I would never want to be a design engineer because I got a second class lower. In Sri Lanka, those days only first class guys can get a design office job. Am I right? Our time.
Yeah, and then second upwards.
Yes, yes. So I didn't have anything, so we started.
The first class guys we sent for PhD approach.
Yeah.
Like two guys like PhD stayed.
Yes, yes, yes. That's true. I believe still maybe the same standard in the industry. So what happened is after few years that I wanted to do design, I worked, midnight oil and refresh all my basic knowledge. Since I had a good background, we learned many things from him. I still remember I can communicate those days, Say I came from from a school where we never speak English. Right, so we started picking up and then I worked all the way overseas and nowadays the language has become like my mother tongue, only I don't understand, I don't speak like Aussie accent. When my boys, my children, when they talk sometimes I don't understand, right, because they speak with Aussie accent, you can see my English is very plain English, right? Okay sir, I think we are very close with the time. Right, so nice pictures, right, there. Why did I design these diagonal strut? Because we could do anchors. There has been a ram the other side, right, vehicular ram, so you can't drill through that. So during design phase we didn't know that, but when they started construction they told me, Ranjan, owner, we can't do anchors, can you have another design? And I said, we go with strut. So instead of one strut, I put two strut. Right? Just to be safe. Okay, right? I think 45 minutes, right?